You know, when you use something like ChatGPT or DeepSeek, have you ever stopped to wonder how it goes from just, predicting the next word to actually solving really complex problems? It almost feels like magic. But it turns out there's a recipe. And today, we're going to break down all the secret ingredients.
So let's get right into it. The huge question at the heart of all of this is, what's really happening in that final stage of training these massive AI models? Are we just sharpening the skills they already have from scraping the internet? Or are we actually teaching them completely new ways to think?
And this right here is the central debate in AI research. You've got one camp that believes that final training phase, the part that uses reinforcement learning, where you reward the AI for good answers, is really just polishing what's already there. But then you have another camp saying, no way, we're seeing brand new reasoning abilities being born. So which one is it?
To get to the bottom of this, we're going to walk through the incredible research that decoded this whole recipe. We'll start with the puzzle itself, then go inside what they call the AI sandbox, and from there, we'll uncover 4 key secrets: the Goldilocks principle, the power of a seed, the mid-training bridge, and why it's so important to reward the right steps.
All right, first up, let's step inside the AI sandbox. Because here's the problem with trying to study AI reasoning in the wild. An AI trained on the entire internet is, well, it's a mess. You have no idea what it's already seen or learned. So to get real, clear answers, you need to create a totally controlled environment.
And that is exactly what a team at Carnegie Mellon University did. They built this AI sandbox, which is basically a synthetic world where they could control every single thing the AI was exposed to, right from the very beginning. This setup let them pinpoint the exact cause and effect of every little tweak in the training.
And their whole framework was built on 3 really smart principles. First, they created their own reasoning tasks so they could dial the difficulty up or down. Second, they made it so they could watch the AI's step-by-step thinking process. No black boxes here. And third, they could systematically change the training data to see exactly what happened. Now that is how you do real science with AI.
And this super rigorous approach led them to their first huge discovery. It turns out, for that reinforcement learning part to work its magic, the tasks you give the AI can't be random. They have to be, well, they have to be just right. Just like in the story of Goldilocks.
It's really that simple. Think about it. If a task is way too easy, the AI doesn't learn anything new. It's boring. But if it's impossibly hard, the AI just gives up and learns nothing at all. The sweet spot, the place where real learning happens, is right at the edge of what it can currently do.
Now this chart shows this idea in action perfectly. Just focus on that rising red line. That line shows what happens when you train the AI on tasks that are just a little outside its comfort zone, what the researchers call its edge of competence. And look at that. Its performance just skyrockets. It's way, way better than when it's trained on stuff that's too easy or just way too hard. The researchers themselves put it perfectly. So here's the big takeaway. Reinforcement learning isn't just about throwing a ton of data at a model. It's about being really smart and curating that data to hit that perfect boundary where difficult becomes possible. That's the zone where true learning happens.
Okay, so we have to train the AI at its edge. But that brings up a new question. What does the AI need to know before we start pushing it? Like, how much background knowledge does it need for these new skills to even start to grow? The answer is shockingly small.
1%. That's it. That's the magic number. You don't need to drown the AI in thousands of examples of a new skill. Turns out, all you need to do is plant one tiny little seed.
And this chart just illustrates the point so brilliantly. See that blue line way down at the bottom? With just a tiny, tiny fraction of a % of exposure to a new problem, the model completely fails as the task gets harder. It just flatlines. But now, look at the red line. With just a 1% seed of exposure during its initial training, reinforcement learning suddenly has enough to grab onto. It can then take that tiny foundation and build on it to solve even the most ridiculously hard problems in that area.
So let's move on to our next secret ingredient, which actually builds on the last one. This is about a part of the training process that's super important, but often gets overlooked. It's kind of the unsung hero that connects what an AI learns in the beginning to what it masters at the end. It's called mid-training.
So what on earth is mid-training? Honestly, just think of it as a bridge. The initial pre-training gives the model this huge, broad base of general knowledge. Then, way at the end, reinforcement learning is super specialized and focused. Mid-training is that crucial phase in between that helps connect the two, getting the model's general smarts aligned with the specific goals of that final stage.
So does this bridge actually make a difference? Oh yeah, a huge one. This chart shows the impact crystal clear.
That yellow line, that's the performance you get using only reinforcement learning. But the blue line, that's what happens when you add that mid-training stage. You get an average performance boost of over 10% on hard tasks. It's a massive amplifier.
And now, for our fourth and final ingredient. This one tackles a classic problem in AI. Sometimes, these models get a little too clever and find ways to cheat. They get the right final answer, but for all the wrong reasons. So how do we make sure they're actually learning to reason the right way?
This is a famous problem called reward hacking. The AI basically figures out a shortcut to get the reward, which is the correct final answer, without actually following the correct logical steps to get there. And that is a huge problem if you want an AI that you can actually trust.
The solution, it turns out, is to change what you reward. This chart compares two different approaches. The bar on the left shows performance when you only reward the final answer. But the bar on the right, that's what happens when you reward the correctness of the entire reasoning process, step by step. The performance on hard problems almost doubles. It's so clear. The journey really does matter more than the destination.
The researchers found that rewarding the process doesn't just improve accuracy, it also cuts down on that reward hacking and leads to more faithful, reliable reasoning. In other words, you're not just teaching the AI what the answer is, you're actually teaching it how to think.
So there you have it, the 4 key ingredients in the recipe for AI reasoning. First, you seed the model with just a tiny amount of exposure to a new skill. About 1% is all you need. Then, you use mid-training to build a bridge to get it ready for specialized tasks. Next, you focus that final reinforcement learning stage right on the model's edge of competence. And finally, you reward the entire thinking process, not just the final answer.
When you put all this together, you get this incredibly powerful, repeatable method for actually teaching an AI to reason. And this all leaves us with one last fascinating question. Now that we have the recipe, how quickly can we accelerate the development of truly intelligent machines? The path forward has never been clearer.